Hi everyone, on this video I'm going to teach you all about right triangle trig, otherwise known as SOHCAHTOA. So we're going to review those three trig functions, sine, cosine, and tangent, but there's actually three other trig functions that we just never told you about last year in geometry. So the main goal for this lesson is to get down those three, sine, cosine, tangent, just kind of refresh your memory on how that works, and also learn what the other three are that I'm talking about. So let's get started. First, let me just remind you that SOHCAHTOA and all these things that we're learning only works on right triangles. Remember, a right triangle is one where there's a 90-degree angle, and with that 90-degree angle, we can label the sides as hypotenuse, opposite, or adjacent based on the angle that you're looking at. So if I'm looking at this angle down here, theta, now by the way, that is what that symbol is called. It looks like a zero with a line through it. It's actually a Greek letter called theta. So if I look there at theta, from this angle, this leg is opposite from the angle, and so we call it the opposite side. Also from that angle, this side over here is touching the angle, so we call it the adjacent side because it's right next to it. And then lastly, we call this one the hypotenuse because it's the longest side and it's right across from the 90-degree angle. Your hypotenuse will always be right across from the 90-degree angle. So that's just a quick refresh on how we label our sides based on where the angle is. If I were to move theta around, like if theta were to be in this corner instead up here, then no longer would this be the adjacent, but over here, this would be the opposite side. And this side right here, since it touches theta, it's right next to it, this would be the adjacent side. The hypotenuse always stays the same because that 90-degree angle is not moving. So the hypotenuse part, that would stay the same. Now, remember the other really important thing that we can do with right triangles is the Pythagorean theorem. This only works on right triangles. It does not work on any other type of triangles, and that is that a squared plus b squared equals c squared, and that allows you to solve for any side of the triangle. So if I knew that the hypotenuse c is, let's say, like 20, and I knew that b is 5, I could, using the Pythagorean theorem, plug those numbers into the formula and solve for a. What that would look like is this, up here at the top of my screen. Now, the downside to the Pythagorean theorem is you have to have two known sides. If you don't know two sides, like if you only know one side of your triangle, what the length is, then you won't be able to use the Pythagorean theorem. So that's the downside. It's a really awesome theorem. It helps you solve for sides of triangles. It does not help you solve for angles, and you have to already know two of the sides. So there are some conditions on it that make it not as great and not as applicable to use to a lot of the other types of triangles. So that is where we use SOHCAHTOA. SOHCAHTOA is really helpful because you only have to know one side of the triangle and one angle. So remember with SOHCAHTOA that the only thing you really need to remember is this acronym. If you can remember that funny word and you can spell it out correctly, then you will know all of your formulas for sine, cosine, and tangent. So let's start with sine. Sine is just the first three letters. Remember, each of these are just three letters. So sine is those three, cosine is these three, and tangent is the last three. So for sine, the S is obviously just letting you know that this stands for sine, the O is for opposite, and the H is for hypotenuse. Same exact thing for cosine and tangent. The CAH right here stands for cosine, is adjacent over hypotenuse, and tangent lets you know that it's opposite over adjacent. Alright, so let's just practice these with the triangle that I have pictured on the screen before I teach you the other three trig identities that exist. So let's do from this angle right here, angle T, I want to set up and figure out what would be the sine of angle T. Well, remember from over here that sine is opposite over hypotenuse. So from this angle, the opposite side is 33, so I'm going to say sine of T is 33 over, and then the next thing I need to do is the hypotenuse. So where's the hypotenuse? That is always the side that is opposite from the 90-degree angle. It's always the longest one, which is 65. So that's what sine of angle T would look like. Let's do the exact same thing, but now with cosine. So cosine of angle T, remember cosine is adjacent over hypotenuse. So what's the adjacent side? The side that touches angle T is 56 over hypotenuse is the next one, and the hypotenuse is always the same, and that is 65. It's always the biggest one on the triangle, and it's always right across from that 90-degree angle. So that's what cosine looks like. All right, and let's do it one more time with tangent. Tangent of angle T is opposite over adjacent. So if I look at this angle, the opposite side is 33, and the adjacent side is 56. Okay? So that's just a quick refresh on sine, cosine, and tangent, and now let me teach you the other three. The other three, so right here on this chart, I have the three that we just practiced, sine, cosine, and tangent. The other three are their reciprocal functions, and they are listed right underneath the one that they're reciprocal of. So let me go through and just first say how you pronounce these. This one that says CSC, that stands for cosecant. And this one right here, that's SEC, you say that out loud as secant. And this one that says COT is cotangent. So that's how you say those words out loud. Now, you might notice that they are just reciprocals of the one that they sort of pair up with. So if we look at sine is opposite over hypotenuse, well, cosecant is just the flip-flop. It's just hypotenuse over opposite. So you just take the fraction and flip it. So when we do these in right triangles, you're going to do them the exact same way we do SOHCAHTOA. It's just that these ones, the bottom row ones, are just the flip-flop of the one that they pair up with. And that's what this bottom part down here is telling you. It's just saying, hey, cosecant is just the reciprocal of sine. And it's just saying over here, secant is just the reciprocal of cosine. And over here, it's just saying cotangent is the reciprocal of tangent. Now, an easy way that I always remembered it when I was in high school, trying to remember which one pairs up with which one. And when I say pair up, I would call these a pair, these a pair, and these a pair, just because those are the ones that are reciprocals of each other. And so how I remembered which one goes with which is I would write it in order like this. Sine, cosine, tangent. And that part was easy for me to remember because that's just usually how we say it out loud, sine, cosine, tangent. It's also the same order that SOHCAHTOA goes in, sine, cosine, tangent. And then if you can just remember CSC, then you'll be able to get all the rest. So I write CSC next to sine, and then I'm going to do the exact same thing going down. I'm going to fill in the letter CSC right here, CSC. And then that helps me remember the other one. So what's the other one that starts with an S is secant. What's the other one that starts with a C? Cotangent. So again, my little trick is write sine, cosine, tangent, and that in that order, that's usually how we say it out loud. It's the exact same order that SOHCAHTOA goes in. Right next to sine, the first one you write is CSC, and then going down, you write CSC and fill in the blanks. And then that shows you that cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So the ones that are right next to each other are the reciprocal functions. Okay, so let's do an example where I'm going to have you evaluate all 6 of them, sine, cosine, tangent, plus the reciprocal functions of the angle theta right here. Now, the only issue is we're going to need to know this side. A lot of the trig functions involve the hypotenuse, and right now we don't know what that side is. The good thing is we do know this side, and so we could easily do the Pythagorean theorem, which says a squared plus b squared equals c squared, and we can solve for c, which is the hypotenuse. So let's plug those numbers in. 5 squared plus 12 squared equals c squared. Now, the order that I wrote these in doesn't matter. You could have flip-flopped them, and it doesn't matter. A and B just have to be the legs. It doesn't matter what order they go in. So let's keep solving this out. 5 squared is 25. 12 squared is 144. If we add these together, we get 169. Now we're trying to solve for c, so what I have to do left is take the square root of both sides, which gives us 13. So by the Pythagorean theorem, I now know that my hypotenuse, the missing side, is 13. So I'm going to erase all this work. If you need to pause the video here to fill in on your paper, go ahead and do that now, and I'm going to erase it and fill in 13 for the hypotenuse. Okay, so now we can continue with the problem, which is evaluating the 6 trig functions of the angle theta. Let's start with the 3 easy ones that we know, sine, cosine, and tangent. So I'm going to start writing out SOHCAHTOA because that's always helpful to have at the top of our paper. And let's just start with the first one, sine. Sine is opposite over hypotenuse. And remember, we're doing it from this angle. So what's the opposite side? That would be 12. And what's the hypotenuse? That is 13. So sine of theta is 12 over 13. And now let's do the same thing with cosine. The cosine is adjacent over hypotenuse. So what's the adjacent side, the side that touches it? That would be 5, and my hypotenuse was 13. So cosine of theta equals 5 over 13. And let's do the last of our easy ones that we already knew. Let's do tangent now, which is opposite over adjacent. The opposite is 12, and the adjacent is 5. So tangent of theta equals 12 over 5. And once you have those 3, and you remember that quick abbreviation trick that I taught you in the last slide, getting the next 3 is really, really easy. So remember how we start is write CSC, and then I'm going to do the exact same letters this way. So I need to write CSC going down this way. So I already have the C, S, C, and then fill in the blanks. Secant, cotangent. And again, I'm doing it this way because cosecant is the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So if I have these lined up here, then doing my next step is going to be really, really easy. In fact, we'll go ahead and do it now. So the cosecant of theta is just the reciprocal of sine. So you're just going to flip it. Instead of 12 over 13, you'll just write 13 over 12. The reciprocal of cosine, which is secant, is going to be flip-flop these ones, 13 over 5. And cotangent, which is the reciprocal of tangent, you just flip these ones, so that will be 5 over 12. And that's it. So once you have your main 3, and once you remember which ones get paired up with which ones, all you have to do is flip the fractions. Okay, so I'm going to have you try that exact same thing on this triangle pictured. Let me get you just started with the setup. Since we don't know the hypotenuse, your first step is going to be use the Pythagorean theorem to find the hypotenuse. Once you have the hypotenuse, I would set up your paper like this. Sine of theta equals, so you're going to do sine, cosine, tangent, following just the order of SOHCAHTOA. I'd probably write SOHCAHTOA out at the top of your screen. And then fill it in CSC, CSC. And all you have to do to get the other 3 over here is just flip the ones that you have here. Okay, so at this moment I would pause your screen, do the Pythagorean theorem to find the hypotenuse, and then fill in these 6 trig values. Okay, so here's my answers. When I did the Pythagorean theorem up here at the top, I got that C is 25. So then using that, I got my regular 3 sine, cosine, tangent values, and then all I did is flip them to get the reciprocals. So now would be a good time to pause your screen again, check your answers before moving on to the next screen. Alright, so this is our last example for today, and then I'll have you guys practice another one on your own, and then we'll call it good. We're going to do the exact same thing in example 2. We're going to find all 6 trig functions. Again, the only issue is I have a missing side right here. This time, it is not the hypotenuse. The hypotenuse is this side up here that says 9. I knew that's the hypotenuse because it's right across from the 90-degree angle, whereas this one touches the 90-degree angle. So the side that I'm missing is a leg, which is either A or B, whichever one you want to call it. Just to make it simple, let's make this one A, this one B, and this one C. So before I get started with the trig functions, let's do the Pythagorean theorem to solve for that leg. So I would set it up like this. A squared, which is 3, so 3 squared, plus B squared equals C squared, which is 9 squared. So let's solve that out. 3 squared is 9, plus B squared equals 9 squared is 81. Subtract 9 from both sides and you get 72. So I got B squared equals 72. And now I'm going to take the square root of both sides. And so I get B equals the square root of 72, which is not a perfect square root. But what we can do is break this down into simplified radical form. So let's break down the number 72 and see if we can find any pairs of 2. So the first factor I think of is 9 times 8. And with 9, I think 3 times 3. Remember, you circle anytime you get to a prime number. And with 8, I think 4 times 2. 2 is a prime number, so I circle that. And with 4, I think 2 times 2. Okay, so then you look for any groups of 2. I have a pair here and a pair here. Both of those numbers can go on the outside. Remember, just one time. So with this one, I'll put a 3. And with this group down here, I'll put a 2. And since this one was just kind of left by itself, that one stays under the radical. So I can simplify that as 3 times 2 is 6, so 6 square root 2. With all of these right triangles, trig stuff, we are going to always be doing simplified radical form. So now I'm going to come back over to my triangle and fill in that b is 6 root 2. And now I can proceed doing the rest of the 6 trig functions. If you need to pause and look at the work on the screen, go ahead and do that now. I'm going to erase everything and just fill this number in here in a clean, nice looking way. Alright, so now would be a really good time to write SOHCAHTOA at the top of your page. And let's start by doing the main 3, sine, cosine, and tangent. So when I look to do sine, sine is opposite over hypotenuse. So looking at this angle, the opposite side is 3, and the hypotenuse is 9. So 3 over 9. Now, I always want to reduce my fractions whenever I can. 3 over 9 reduces to 1/3. So I'm just going to write my answer as 1/3. In fact, I'm going to erase my screen and fill that in over here. That way I have room to do my reciprocal functions on this side. Okay, so now let's move on and do cosine. The cosine of the angle is adjacent over hypotenuse. So when I look at this angle, which side is the adjacent leg, the side that touches it? It would be this one, 6 square root 2 over hypotenuse, and the hypotenuse is the same, which would be 9. And then again, just make sure that your fractions are in reduced form. 6 divided by 9, I can reduce that to 2/3. I still have that square root 2 hanging there, but I can just reduce this part of it, 6 over 9, to 2 over 3, so I want to make sure we do that. I'm going to erase it and put this one here. Okay, so the last one I need to do is tangent. Tangent is opposite over adjacent. So let's come back to my angle. My opposite side would be 3, and my adjacent side is 6 square root 2. So let's write that down. 3 over 6 square root 2. Now there's 2 problems with the way this is written. The first main issue I see is that this fraction can be reduced to 1/2. 3 divided by 6 is the same thing as 1/2. I'm just going to erase that right now and write 1/2 instead. So that part will already be done. The second issue is that I have a square root in the denominator, which we can never have. We always want to clear the denominators and not have any square roots in the denominator. So remember, a really easy way of getting that out is just multiply both top and bottom by square root 2. The reason we do that is because these ones right here just multiply together to be 2. So the bottom, this denominator of the fraction really just says 2 times, and then what's in this red box is just equal to 2, which we know that that is 4. So when I do that, the denominator is just 4. So let me erase that and just write 4. And in the top, we have 1 times square root 2, which is, I don't really need to write that times 1, so I can just say that's square root 2 over 4. So I'm now going to put this over here for tangent theta. Alright, so now that I have these main 3, I can do my shortcut, which is this, CSC, C, and then going down SC, fill in the blanks, and all I have to do is flip the fractions that I already have, and I'm done. The only thing to watch out for is if you do end up having a square root in the denominator, you need to clear that out. So let's do the first one. The cosecant is just going to be the reciprocal, which would be 3 over 1, which is just the same thing as 3. So I'm just going to write that as 3. Secant would be, if I flip this, that would be 3 over 2 root 2. And that's correct, but I do need to rationalize the denominator because I can't have a square root in the bottom. So let's multiply both top and bottom by square root 2. And in the bottom, this gives me 4. So let me erase that and write 4. And now that I no longer have a square root in the denominator, I'm good to go. And let's do cotangent. Just flip what we had previously. Again, the only issue is I have a square root in the denominator. So multiply both top and bottom by square root 2. This bottom part will just simplify to 2. And I'm almost done. But now that I've done that, this fraction, 4 divided by 2, can be simplified. 4 divided by 2 is 2. So now I'll write that as 2. Or 2 over 1 if that makes it easier for you. So I'll erase this, oops. And I'll write 4 over 2 as 2 over 1. And then you might notice and say, do we really need to write it over 1? No, we don't. So I could just leave it as this, 2 times square root 2. Let me clean that up a little bit and write that in a better way. 2 square root 2. So it started from me just flipping this and then just rationalizing the denominator and simplifying a fraction. Pause the screen here if you need to look this over and check your answers before I have a you try. Alright, so here's the one you guys are going to do on your own. The very first step is find that other side of the triangle. Note that this is not the hypotenuse. So maybe we call this A, maybe we call this part B, and this part C. So step 1 would be to find B, the other leg of this right triangle, and then fill in your 3 main trig functions, sine, cosine, and tangent. Once you have those, it'll be really easy to get the reciprocal functions, but we'll start with these 3 first. I'll show my answers for these 3, and then I'll move on and show my answers for the other 3. So step 1 was finding B of the right triangle. Up at the top, I did my work for the Pythagorean theorem, and I got that B squared equals 20. So when you take the square root of both sides and you get B equals the square root of 20, make sure you're breaking down square root 20 as much as you can, and I got that that's 2 square root 5. So now I know that 2 square root 5 was my missing side over here. And so from this step, now we can fill out sine, cosine, and tangent. I'm going to pause, clean up my screen, and then fill in my answers here. If you haven't filled in your answers yet, pause the video and do that. And again, make sure that you're not writing any fractions with a square root in the denominator. Make sure you clear those out and rationalize. Alright, so check these 3 answers with me. The ones that I boxed in green are my final simplified form. So some of them just required reducing the fraction, like this one. Some of them also required rationalizing the denominator. Like when we had to do tangent, I couldn't just leave square root 5 in the denominator. I had to multiply both top and bottom by square root 5 to rationalize the denominator, giving me my final answer, which is boxed in over here in green. So at this point, I would pause the screen, check these 3. I'm going to erase it in a second. That way I can set up my other 3 as the reciprocal trig functions and get all the answers on one page. So here's my main 3, and from here I can easily get my reciprocal functions. Remember how I write it is CSC and then CSC, and fill in the blanks here. And so now all I have to do is flip the fraction that it's next to. So for cosecant, I just flip sine. So that would be 3 over 2. This fraction cannot be simplified. There's no square root in the denominator, so we're good to go as it is. For the next one, for secant, I'm just going to flip this fraction. So that would be 3 over root 5. Now there is a problem because we do have a square root in the denominator. So multiply both top and bottom by square root 5 and simplify. Square root 5 times square root 5 would give me 5. So I'm going to erase that and write 5. This fraction cannot be reduced anymore because you cannot reduce 3 divided by 5 any further. So we can't do any more. Now, sometimes some of you think that this 5 and this 5 should cancel out. That does not happen because these are not both 5s. This is square root 5 and this is the regular number 5. So they definitely do not cancel each other out. And lastly, for cotangent, let's go ahead and flip it. So 5 over 2 root 5. And again, I have the exact same issue with the root 5 being in the denominator. So let's multiply that out. Both top and bottom by root 5. This part right here, what I boxed in yellow, gives me the number 5. So let me write that down. And the denominator would just give me 2 times 5, which is 10. So let me erase this and write the denominator as 10. And then one more thing that we should notice is that 5 divided by 10 is the same thing as 1/2. So I can erase this part and just write it as 1/2. And then there's really no point in writing the times 1. So my final answer can just be root 5 over 2. And I'll leave it just like that. Okay, and that's it for today. The main goal is that you understand how to set up the trig ratios for all 6 trig functions. If you understand that, then you are good to go for today, and you can do the bookwork problems that are assigned online that correspond with your weekly assignment. Have a great day, you guys, and I will see you later.